Well, here we are in West Virginia. Doesn't everybody safari in West Virginia? Anyways, I'm ready for joke of the day. Are you ready for joke of the day? Of course you are, because it's the best part of the day. So, what does a clock do when it's hungry? Well, it goes back 4 seconds. Goes back 4 seconds. Goes back 4 seconds. Okay, anyways, it's time to go back into the idea of absolute value. But we're going to take absolute value, we're going to push it a little bit further and not just talk about absolute value in an equation, we're going to talk about absolute value inequalities. So first we need a little bit of a definition. Let's recall what absolute value means. Now remember, absolute value means distance from zero on the number line. So when I'm talking about an absolute value inequality, say for instance this type of situation, and then what this is saying is what is inside that absolute value symbol is not going to be just a number anymore, it's going to be an expression. And recall, an expression will have numbers and variables, no equal sign, but I'm going to have more than just a single number or even more than just a single variable in there. I will have an expression. Inside that, now it's saying that C is a positive number. So remember what this is telling me is absolute value being distance from zero is neither positive nor negative. It's just simply distance from zero. So in this particular situation, what it's saying is that distance from zero is going to be smaller than whatever that number is. Distance from zero being smaller than that. So what happens is, let's take a look at this number line. This helps us to understand how to set up the way to solve this. So if I'm looking at this number line, and whatever this number is going to sit right here. Now recall that when I'm talking about distance from zero, and I'm saying that's the distance, well, I could have a distance going up this far, but I could have that distance going on the negative end of the number line. So that would be on this end back down here. So in other words, when I talk about that distance, either the positive of that number or the negative of that number could provide me with that distance. But remember, this is saying that the distance that I'm talking about is actually going to be less than that distance, smaller than that distance. Well, here's the thing. If I'm simply looking at this side of the number line and what's marked in red is that distance, then smaller than that distance would be, say for instance, anything back in here would have a distance smaller than that much right there. So if that's the case, then when I flip it over to the other side of the number line, then the same idea is happening. If this is the distance, smaller than that distance could be anything in here. So if that's the case, and I'm talking about all these distances that are between here and here, that means that whatever goes in there is going to be wedged between this number, and that creates this compound inequality. Now we've looked at compound inequalities before and how to solve them, but this is what's happening. So it's saying that this expression is going to sit somewhere within this red line right here. So if the expression is going to sit somewhere within that red line, it's going to either sit above that number down there, or it's going to sit below that number down there. And like I said, what that does is that creates this compound inequality, and we can solve the compound inequality. So let's just kind of sit on that one for just a minute, and let's take, before we get into the next idea, and let's take a look at an example that would go along with that. So in the examples that I'm going to give you, and I'm going to have 5 of them, what's going to happen is we're going to solve each one of them, we're going to graph the solution set on a number line, and then we're going to express that solution set in an interval notation. So in this particular example, what it's saying is the stuff inside the absolute value, and right now I kind of don't care what that stuff is. I'll put my hand over top of it so I don't confuse myself. The stuff in there, its distance from 0 on the number line is going to be smaller than a distance of 20. So if I look at the number line, here's 0, a distance of 20 would be up to here. That's a distance of 20. But recall that I can also have a distance of 20 back this way as well, and that takes me to a negative 20. So what happens here is that says that all this stuff in here could sit anywhere in here. So this stuff right there could sit anywhere along here, meaning that it's going to be, its position is going to be smaller than a 20. Its position is going to be bigger than a negative 20. So that creates this compound inequality that it's greater than or equal to that negative 20. And at the very same, whoops, don't forget that plus 2. And at the very same time, it's going to be less than or equal to a positive 20. So the position of this is going to be between those two numbers. That creates this compound inequality. Now remember, in order to solve a compound inequality, my whole goal is get everything away from that x right there. So I'm going to do everything it takes inside here to get the x by itself, and whatever I do in here to get the x by itself, I'm going to do here and here as well. So in order to get this x by itself, first I'm going to remove this 2. I'm going to get it out of the way. And I'm going to do that to every single part of this compound inequality, all 3 parts. Now when I subtract the 2 over here, I get a negative 22. When I subtract the 2 in the middle, I get 3 times x minus 1. And when I subtract the 2 over here, I get an 18. Now recall what it takes to flip these inequality symbols. Yes, it's whenever you multiply or divide by a negative. Did I multiply or divide by a negative anywhere? Nope. So I'm not going to flip those symbols. Now, the next thing that I'm going to do to get that x completely by itself, because remember, that's my goal, get the x by itself. The next thing that I'm going to do is go through and divide by a 3 here, which means I also need to divide by 3 here, which means I also need to divide by 3 here. So when I divide by 3 on this side, I get a 6. When I divide by 3 in here, I'm left with just an x minus 1. And when I divide by 3 over here, it won't divide nice and cleanly. I will simplify my fraction if I can, and it won't, so I'm going to leave it alone. Do I flip these symbols? Because I divided right there. But remember, only when you divide by a negative. I divided, yes, but not by a negative. So I'm not going to flip any of these inequality symbols. Now, remember, once again, I want to get this x by itself. So what I'm going to do now is add a 1, add a 1, and add a 1. When I add a 1 over here, I get a 7. And here I get an x. And when I add a 1 over here, now I need to remember what it takes to add fractions. I need that common denominator. So I have a 22 over 3, a negative 22 over 3, plus a 1 is going to be a 3 over 3, and negative 22 over 3 plus 3 over 3. I've got that common denominator of 3 that I'm going to keep. And now I'm going to add those numerators. Negative 22 plus 3 is a negative 19. Clean this up a little bit so we can see better. So here is my solution. That the number that I can put right here and make this a true statement, that number is smaller than a 7, or it could be a 7 because of the equal to part. At the very same time, that number is bigger than a negative 19 over 3, or it could be a negative 19 over 3. So here is my solution. Now remember, it said graph that solution set on a number line. This is not my number line solution set. So what I have to do now is I have to create a number line. And on that number line, here's 0, here's 7, here's that negative 19 over 3. Now remember, everything that works is going to be smaller than that 7 or 7 itself. So smaller than that 7 is going to be everything back here. Now, it's going to keep on going forever, except that those same solutions, they also need to be bigger than that negative 19 over 3. Now, bigger than negative 19 over 3 is going to be everything up here. So it's everything wedged between the two, which you can see is kind of how I started, because I said the position is going to be wedged between these two numbers. So I started with this look of a number line. I'm finishing with that look of the number line. But this tells me what x is. This only told me the position of the stuff that's inside the absolute value. So this is my actual answer, except that, remember, I need to decide how am I handling that negative 19 over 3. Remember, it could be the negative 19 over 3. And how do I express that? Yes, with a bracket. Those old rules come back to haunt you. You can't forget that stuff. And then how am I going to handle my 7? Once again, there's an equal to part, so that means put a bracket on it. So here is my number line graph to represent that solution. Now recall, we've talked before about interval notation. Interval notation is simply math symbols to represent that picture. So the math symbols that would represent this picture, remember, you start as far left as possible, you're only going to step on those solutions. So when you start your walk as far left as possible and then you start heading towards the right, that means I'm going to start back here at a negative 19 over 3, which is included, so it gets a bracket. I'm going all the way up to the 7. It is as well included, so it gets a bracket as well. And so there is my the interval notation. Here's my answer, here's the graph, here's the interval notation. So that's what happens whenever you have your absolute value inequality and the inequality is going down in this direction. In other words, this stuff here, the distance is smaller than that 20. Distance smaller than that number. Now let's take a look at another idea though, with the concept of that distance being bigger than that number. This is the second situation. So again, this absolute value simply says I'm talking about a distance, the stuff inside here, its distance is going to be bigger than that number when I look at a number line. So here's my number line, and when I'm talking about a distance that's bigger than this, now the distance itself of this, again, would be from here to here, but I want a distance that's bigger than that. So if this is the distance, bigger distances would be like from here to here, from here to here, from here to here. So basically it's everything out here. These numbers will create bigger distances than that distance right there. And then if I go on the other side of the number line, here again is that distance of C. And so when I'm talking about bigger distances than that, and I'm only looking at this side, here is that distance. So if I want a bigger distance, that's going to be out here, out here, out here. So instead of this, it's going to be everything out here. So what that tells me is the stuff in there, that expression, could sit out here, or it could sit out here. So the U could sit out here, the U could sit out here. And that does not create a compound inequality because this one had it wedged between. That U could sit anywhere between the two. Here, the U is going to sit on this end or on this end. So this is not a wedged in situation. This is a tails situation. So this U could either be smaller than this negative C, which is right here, U smaller than negative C, or this U could be bigger than the positive C. U bigger than the positive C. And again, what I set up right here is just position. It just gives me the position because then I can solve those two separate inequalities. This is an and situation. And means overlap. They're together. It's a compound inequality. This is an or situation. Or means one or the other. It's on the tails. So let's take a look at that example. Flip this back around. Enjoy the scenery while I clean up this board here. The board doesn't clean as well as it used to, so bear with me a minute and enjoy all the jungle sounds and the jungle, everything that's in the jungle, which can be a little terrifying if you ask me, but, all right. So my next example then is going to say absolute value of 2x plus 2 divided by 4 greater than or equal to 2. So here again is that situation where it's the distance of this, whatever the stuff is inside, and I'm going to put my hand over so it doesn't confuse me. Whatever that is, when I talk about its distance from 0, that distance will be bigger than 2. So I'm going to take this initial look at the number line so that I can figure out where the position of this is going to be. Here's 0. A distance of 2 would be right there. From 0 to 2 is a distance of 2. But remember, this said a bigger distance. The big end is with the big side, small end's with the small side. So this distance is bigger than the 2. Bigger distance is going to be everything out here. But I can flip that over to the other side and say, okay, a negative 2 has a distance of 0. But again, I want bigger distance, so that's going to be everything on this side. So what this is telling me is, the stuff in here, that 2x plus 2, it can be positioned back here. The stuff inside, the 2x plus 2 over 4, can be positioned back here, or it can be positioned up here. That's going to create the two separate inequalities, not a compound inequality. It's not an overlap situation. Two separate inequalities. So that 2x plus 2 divided by 4, if it's positioned back here, then that means it is smaller Small a, those are the small numbers, smaller or equal to that -2. Or this stuff right here, that expression, could be positioned up here. And if it's positioned up here, then it's greater than or equal to the +2. Again, big into the inequality symbol goes with a big number. I have two separate inequalities that I need to solve. Now, in both cases to solve it, I'm going to multiply by 4 so that that will cancel, which means multiply this by 4, giving me a 2x plus 2 greater than or equal to -8. Yes, I multiplied, but not by a negative. That's the only time I flip that symbol, when I multiply by a negative. So I'm not flipping the symbol. So again here, multiply by 4 to cancel, giving me 2x plus 2. Multiply by 4 over here. Again, not flipping that symbol, because even though I multiplied, it was not by a negative. And now to solve each one of these, what I'm going to do is I'm going to subtract 2, giving me 2x less than or equal to -10. And I'm going to subtract 2 here, giving me 2x greater than or equal to 6. And now what I'm going to do is to take both of these and divide by 2, giving me x. And again, I divided, but not by a negative, so I'm not flipping the symbol. X less than or equal to -5, and dividing by 2 here gives me x greater than or equal to 3. So here's my two solutions, and remember, this is not a compound inequality solution. This is not an overlap situation. Because if I go to graph this, and this is the importance of doing that graph on the number line, that graph is going to say, okay, here is 0, here is 3, here is -5. Now notice this says the answers, those x's, and I'm shading the answers, they are smaller than a -5. Well, on this number line, we're smaller than -5. Absolutely, it's back here, and I'm going to shade what works. Now I'm going to shade this arrow because that's going to go on forever. At the same time, it says, wait a minute, greater, they could be these, or they could be these. So these answers are bigger than 3. Now on this number line, where's bigger than 3? That's up here. So I'm going to shade that arrow as well because it's going on forever. And again, you can see this pattern follows what I started with. So when you figure out the position, that picture should be the type of picture that you see in the end for your answer number line. So again, I've got to figure out how to handle the -5, how to handle the 3. There's an equal to and there's an equal to. That means brackets on each one of these. Clean that up a little bit there. And bracket on this one as well. So this is my graph answer. And again, the interval notation is math symbols to represent that picture. Now remember, those math symbols, I start walking as far left as possible and I step on solutions. I only step on what's shaded. So as I go as far left as possible, that arrow means I'm going on forever in that direction. That means I'm going to start way back here at -infinity. And infinity always gets a parentheses. I'm going all the way up to, and that's what a comma means, go all the way up to the -5. Now remember, because that -5 has a bracket, it's going to take a bracket right there on its interval notation. Now what I'm going to do is I'm going to skip over all this stuff right here and pick it up at 3. So I'll pick it up at 3, which gets a bracket because it's included. I'm going all the way up to positive infinity. Let me get this out of here so we can see it a little bit better. There we go. It's showing up a little bit better. And infinity always gets a parentheses. Now, to show that these two go together, because they're part of one big picture, what I'm going to do is I'm going to put a U between the two, and the U means union. Union means I'm going to unionize, I'm going to put those two together as one big interval. So, this is what happens, again, whenever you've got absolute value that's greater than this number over here. It creates tails. And so then you can create two separate inequalities, solve each one of them, remembering that your answers are two separate answers, and that creates tails in your graph as your answer, and that creates a union situation in your interval notation. Now, I want to practice just a few more because this is a concept that people really struggle with. So let me clean this board up here. I'm going to go ahead and get the directions off because I think we know at this point what we're doing. We're going to solve it, we're going to graph it, we're going to write that interval notation that expresses in math symbols what that graph looks like. Pardon me while this takes so long. The board has been through a lot these days, and it's really, really having a rough time now. It's not erasing so easily anymore. Okay, so let's try another one. Example C. And this time we've got a -3 absolute value of x plus 7, and that's greater than or equal to -27. Now what I want to point out in this example is, as soon as you see that greater than, most people think, oh, okay, my graph is going to be tails. But I got to be careful, because notice that I can only talk about that concept when I only have absolute value over here and nothing else. If we go back to those directions, or that initial concept that I talked about here, notice the absolute value was by itself. There was nothing else with it. Same thing here, nothing else with it. So I need to get the absolute value completely by itself, because remember, absolute value means distance from 0 on the number line. I can't talk about distance from 0 on the number line until that's all that there is there. If I've got this extra stuff like this -3 being multiplied to the absolute value, I can't talk about distance anymore, because I'm saying that distance is going to be multiplied by a -3. I got to get the -3 out of there to get the absolute value by itself. So how do I get rid of that -3? Certainly, I'm going to divide it, because right now it's being multiplied, and the opposite of multiplication is division. That will get it out. So these will cancel. That gets that absolute value completely by itself like I wanted to happen, and a -27 divided by a -3 is a 9. But notice that I've divided by a negative. What happens when you divide by a negative? Absolutely, you flip that symbol. So I'm going to flip the symbol this time, and I go, oh, it's not tails. My graph is not going to be tails at all, because this one now says to me, okay, the stuff inside, whatever's in there, when I talk about that distance from 0 on the number line, that distance is going to be smaller than a 9. So when I look at my graph, or my number line here, here's 0, there's a distance of 9, smaller than that distance is going to be everything in here. But if I go to the other side of the number line, a -9 will also give me a distance of 9. But when I'm talking about a smaller distance, that's smaller than this, that's still going to be everything in here. So in other words, the stuff in here can be positioned anywhere from here to here. And that creates that wedged between idea. That creates the compound inequality. So that stuff inside here, well, it could be smaller than a 9 or equal to the 9. But at the same time, it could be bigger than, remember, big N goes with the big side, a -9, or equal to that -9. That creates the compound inequality that I'm going to solve. And in order to solve it, I'm just going to subtract a 7 from both sides. On this side, I get a -16. On this side, I get a 2. That gets the x by itself. Do I flip that symbol? Nah, didn't even multiply or divide, let alone multiply or divide by a negative. And that's the only time I flip the symbol, is when I multiply or divide by a negative. Ta-da, the x is by itself, so that is my answer. Now I'm ready to graph it, because remember, this graph just kind of got me started. That was not my answer graph. My answer graph is saying, okay, I'm going to shade the x's, the solutions. So as I look at this number line, and I go, okay, here's 0, here's 2, here's -16. Those answers, they are smaller than 2. Smaller than 2 is everything down here. And as well, they are bigger than a -16. Big end is with those numbers. Bigger than a -16 is everything up here. So it's wedged between, just like I saw here. And I just need to decide how to handle that -16, how to handle that 2. Notice that both of them have the equal to part. That means brackets. So there's my answer graph. And once again, that interval notation, math symbols to represent this picture, I'm going to start walking as far left as possible. I only step on what's shaded. So I begin my walk back here at -16, and I go all the way up to, that's what the comma means, all the way up to that 2. And the 2 is included, so it gets a bracket. The -16 is included, it gets a bracket as well. So again, what I wanted to point out here is, just because you see this in the beginning, that would tell me, oh, it's tails. It wasn't. It was actually wedged between, but it had to do with dividing through by that -3 that flipped that inequality symbol around. So we've got just two more that I want to look at. You know I like to make sure that nothing stumps us, that everything feels comfortable, and we are rock stars at this stuff. So let me get two more examples here for us. And in this one we've got 5 times 2x plus 1 minus 3 greater than or equal to 9. Now notice again, I would think that this is going to be tails because of the greater than, but I got all this extra stuff over here, and I can't talk about absolute value being distance from 0. I can't talk about distance from 0 until that's all I've got there. So I've got a couple things I got to get rid of. I got to get rid of that 5. I got to get rid of that -3. Use the way that you would solve equations, and you know that if you solved an equation, you'd get rid of that 3 first. So I'll do that first. And now I'm going to get rid of that 5. So I'm going to divide through by 5 now. And that gives me my absolute value completely by itself. Now I'm not flipping that symbol because I did not divide by a negative, and that's the only time I flip the symbol. Now I know that there's a fraction there and that's very scary, but we can handle these fractions. We're okay with this. Now remember, what this tells me is the stuff inside there. When I talk about its distance from 0 on the number line, its distance is going to be bigger than a 12/5. So as I look at my number line, and I go, okay, here's 0, a distance of 12/5 would be from here to here, but I'm talking about a bigger distance. That's everything back here. The position, these numbers have bigger distances than 12/5. And on the other side of the number line, -12/5 would give me a distance of 12/5, but all the numbers back here would also have distances bigger than that -12/5. So the stuff inside here could sit back here, or that stuff inside there could sit back here. Now if it sits back here, my 2x plus 1 is going to be smaller than or equal to a -12/5. Or if it sits up here, then that stuff inside is going to be positioned greater than or equal to +12/5, creating two separate inequalities that I need to solve. Now in both of these cases, I'm going to subtract 1, and that will give me 2x. Now notice I did not even divide or multiply, so I'm not flipping the symbol. And -12/5 minus 1, well, -12/5 minus 5/5, because I need that common denominator. Now that I've got it, I'm going to combine those numerators. -12 minus 5 is a -17/5. And on this side, I'm left with 2x. Again, didn't even multiply or divide, so I'm not flipping the symbol. 12/5 minus 1, well, 12/5 minus 5/5 will give me 7/5. And now I'm ready to divide by 2. But we've looked at something like this before where we say, okay, dividing by 2 is fine here, but wow, that's ugly. So we know that dividing by 2 is the same thing as multiplying by its reciprocal. Remember, dividing by 2 is the same thing as multiplying by its reciprocal. So I'm going to go for the jugular because it's cleaner and faster. It's cleaner to just simply do this and multiply those fractions. Now, when I multiply these two, they'll cancel out like it's an x by itself, like I wanted. And on this side, I'm going to cancel on those diagonals, but nothing's happened. Because remember, when you multiply fractions, cancel on those diagonals, cancel up and down, and then shoot straight across. There's that gang symbol. So nothing cancels on these diagonals, but I'm going to multiply across and get a -17/10. Now, I did multiply by half. Do I flip the symbol? Nope. Not until I multiply or divide by a negative. So there's my answer. Same thing's going to happen over here. Multiply by a half, multiply by a half. These will cancel. I'm left with x. And once again, cancel on those diagonals, cancel up and down, shoot straight across. Nothing's canceling on either of the diagonals. Nothing's canceling up and down. Let's shoot across. 7 times 1 is 7. 5 times 2 is 10. And once again, not going to flip the symbol because I didn't multiply by a negative. So here's my answers, recalling that this is not a compound inequality. Not a compound inequality. Two separate inequalities for my answers. But now I'm ready to put it on a number line. And so on that number line, here's my negative 17 tenths. And here's 0. And here's 7 tenths. Scoot it down. I have a very bad habit of putting it right up against there, and then I can't put my parentheses or my brackets. Here, everything that works is smaller than that negative 17 over 10. Well, here's negative 17 over 10. Where's everything smaller? Yeah, back here. And I'm going to shade the arrow because it's going on forever. They're also greater than a 17 or 7 over 10. Where's bigger than 7 over 10? That's up here. And once again, I'm going to shade that arrow because it's going on forever. Now, this one gets a bracket because of the equal to part. This one as well gets a bracket because of the equal to part. So there is my graph answer. And one more time, I'm going to put that, that interval notation to represent, math symbols to represent what's happening here. I'm going to start walking way over there. Way over there is negative infinity. And infinity always gets a parentheses. I'm going all the way up to that negative 17 over 10, which gets a bracket. And then I'm going to skip over, but this one's going to be included. So I'm going to put that U, and I'm going to pick it back up here at that 7 tenths, which gets a bracket. I'm going all the way up to positive infinity, which always gets a parentheses. Now, just to make it look nicer, that answer, we'll just put it right up in here, just so you can see it spread quite nicely. Negative infinity to negative 17 tenths with a bracket, union with my 7 tenths and infinity. And that's what your interval notation will look like. And hopefully what you're seeing, again, it's kind of a double check. I ended with tails, that's how I started up here, to give me that position of where the stuff inside, that expression inside, where it's going to sit on that number line. Okay, one last one, because I just really, really like for us to see lots of examples and be very comfortable with all of this. I think we're getting the hang of it. I think we feel pretty good about it. But I think this last one will just seal it for us. There's no seals here in the jungle. No way. So let's take a look at this. One more. A, B, C, D, and example E. So I've got a negative 2, absolute value of 5 minus x, absolute value less than a negative 6. So once again, what happens here is I'm talking about distance from 0, but I can't really talk about that until that's all that's there. So I need to get rid of that negative 2. So I'm going to divide both sides by that negative 2. And that will get it out of there, giving me absolute value of 5 minus x. And negative 6 divided by negative 2 is 3. But notice what happened here. I divided by that negative. That's going to flip my inequality symbol. So where I thought this was going to be wedged between, it's not going to be wedged between because now it's going to be tails. But at this point, I'm going to look at this and I'm going to say all that stuff inside, its distance will be bigger than 3 on the number line. So here's my number line. Here's 0. There's a distance of 3. Where else do I have a distance of 3? Oh, I'm sorry, not where, well, yeah, I have a distance of 3 back here as well. But what I really want to point out now is this stuff, its distance is bigger than 3. So bigger distances are out here. Bigger distances are as well out here. So this stuff could be positioned back here. It could also be positioned back here. So that 5 minus x could be smaller than a negative 3, or it could be bigger than a 3. Remember, small n goes with a small number, big N goes with a big number. So if this is smaller than negative 3, the small n is going to go with this. And if this is bigger than a 3, then the big N is going to go with that. Again, creating two separate inequalities that I need to solve. So in both cases, I'm going to subtract my 5, giving me negative x less than negative 8. And then here, when I subtract that 5, I get negative x greater than negative 2. But remember, I want x, not negative x. So I'm going to go through and divide by a negative 1. And basically what happens is it changes the signs. But notice I divided by a negative. What happens to my inequality symbol? Absolutely, it flips. And same thing's going to happen right here. I divided by a negative. I'm going to flip that symbol. So here are my two separate inequalities. Now notice that with those two separate inequalities, when I go to graph them on the number line, I have 0 here, 2 here, 8 here, and I'm going, oh my gosh, usually I've got negatives down there. That doesn't always happen. You've got to go with what you've got there. But remember, this says the numbers that work are bigger than 8. Where's bigger than 8? Absolutely, that's up here. So I'm going to shade everything up here. I'm going to shade the arrow because it goes on forever. They're also smaller than 2. Where's smaller than 2? That's back here. And once again, I'm going to shade that arrow because it's going on forever. And you can see I started with tails, I'm ending with tails. So this is working out like I expected it to. Even though right here I thought it was going to be wedged between. Now I've got to figure out that 8. Does it have a bracket or a parentheses? Aha! There's no equal to part this time. So it does not get a bracket. It gets a parentheses. And same thing here. Does not get a bracket, gets a parentheses. So there is my, my answer graph. And now that interval notation, the math symbols to represent that picture, go as far left as possible. That's back at negative infinity. I'm going to go all the way up to the 2. This time 2 gets a parentheses. And I'm going to pick it up at 8, which gets a parentheses. I'm going to go all the way up to infinity. And I'm going to unionize those two. And there is my answer graph. Or sorry, my interval notation. Now one thing that I want to point out to you is a lot of people, they will take this answer and they will try to put it as a compound inequality answer. And so what I get a lot is this kind of stuff. They'll say the x is bigger than 8, and then they'll put it like this and go like that. Because this says 2 bigger than x. But think about what this means. Even though you've got your symbols lined up right, big ends with the x, small ends with the 8, big ends with the x, small ends with the 8, small end with the x, big end with the 2, small end with the x, big end with the 2. And then what happens is when you go to graph that on the number line, here's 2, here's 8, and suddenly people start doing this right here. Because they think it's wedged between. But notice that what this says is the x is smaller than 2. Smaller than 2 is back here. The x is bigger than 8. Bigger than 8 is up here. See, it's not a compound inequality. It's not an overlap situation. So I can't write it this way because this way indicates the graph is going to overlap. The graph is clearly not overlapping. So I need to write it as two separate inequalities. Don't put them together because putting together indicates overlap. So I hope this helps with those absolute value inequalities. And like I said before, to summarize, basically what happens here is whenever my distance is smaller than this particular distance, smaller distances are going to be wedged between, creating that compound inequality. Whenever that distance is greater than that number, that's going to be a distance out here or out here, creating tails. Tails creates two separate inequalities because the stuff is either going to sit back here where it's smaller than the negative c, or the stuff is going to sit up here where it's bigger than that positive c. And it's not an overlap situation. It's not a compound inequality. It's two separate inequalities. I hope that helps. Have a great day.